Good morning, dear student. In previous lecture, we already discussed the definitions of composite or different components of this composite material. That is, one is continuous phase, another is discontinuous phase. The continuous phase is called as matrix, and the discontinuous phase is called as a reinforcement. So, in today's lecture, we are very much interested in the classification of composite material. The classification of this composite material is based on uh, the continuous phase as well as the discontinuous phase. Okay, so it will base on the matrix material which is present in the composite material and the reinforced material. Okay, so the classification based on the matrix material as well as the reinforced material. So in today's lecture I will discuss uh, the classification of this composite material, because we know that is matrix matrix plus reinforcement. Matrix plus reinforcement results into composite material. Composite material. Matrix plus reinforcement, which is equal to the composite material. So we are very much familiar with the example that is concrete, in which if you consider the example that is concrete, then concrete in which cement is your matrix. Cement is your matrix. Okay, and whatever the remaining uh, particles, we can say that the particles means the sand. Okay, particles such as sand, different particles. Okay, and they are considered as reinforcement. They are considered as a reinforcement. So at least you should know the matrix and reinforcement combine to gives the composite material, and we already discussed that the matrix and the reinforcement have individually different physical and chemical property. Okay, and when they combine to form a new material called composite, and this composite, in this composite material, the every individual, that is matrix and reinforcement, retain their properties. So let's discuss the classification of this composite material based on the matrix material. So this is based on matrix material. The first classification, it is based on the matrix material. Okay, so which matrix materials are used in this composite? Matrices. Okay, so according to the material or the matrices used in this composite material, they are classified into different types. The first one is your polymer matrix composite. Polymer matrix composite. So in this case, the polymer is your matrix. Polymer is your matrix component. Okay, it is your continuous phase. Okay, second, that is metal matrix composite. Second, that is metal matrix composite. First one is your polymer matrix composite, second metal matrix composite, third one is your ceramic matrix composite. Ceramic matrix composite. Ceramic matrix composite. And the last one is your carbon and graphite. Carbon and graphite. So this is the classification of this composite material based on the matrix material. Okay, so we know that the composite, it is a combination of matrix as well as reinforcement. So whenever the polymer is used as a matrix material, then it is considered as a polymer matrix composite. When metal or different alloys are used, okay, and then it is considered as a metal matrix composite. Then ceramics are used, such as glass, okay, and then Al2O3, okay. So these are the some ceramic materials, they are called as ceramic matrix composite. And the last one is carbon and graphite. So let us discuss one by one some important points regarding to this polymer matrix, metal matrix, ceramic, and carbon and graphite, okay. So let us discuss one by one. That is the first one, that is polymer matrix composites. Polymer matrix composite. So we are very much familiar with this polymers, the word polymers, that is polymer matrix composites, okay. So if you consider the advantages of this polymer matrix composite, the one is that they're having extremely high temperatures. So they can withstand at high temperature, extremely high temperature, okay, that is up to 1930 degrees Celsius. It is not polymer matrix, sorry, I will make a mistake here. This is not polymer matrix. So this polymer matrix composite. So polymer, so we know that polymer. What is this polymer? Polymer, they are the complex, they are complex and giant giant molecule giant molecule, and are different, and are different from low molecular weight component, from low molecular weight component or compounds, okay. So we are very much familiar with these polymers, okay. They are the complex and giant molecule, they are having high molecular weight. And if you consider uh, this polymeric material are classified into two types. One is thermosetting and another is thermoplastic. So they are classified into two types, that is thermosetting, and second one is your thermoplastic. So we are very much familiar with this thermosetting and thermoplastic polymers. So the thermosetting polymers that becomes an infusible and insoluble mass on heating are called thermosetting. So if you consider this thermosetting, the polymers becomes they becomes infusible and insoluble mass on heating, okay. And if you consider the thermoplastic, they are softened on heating and can be converted into any shape. So we are very much familiar with this. So they are softened on heating, and can be converted, and can be converted into any shape, can be converted into any shape, and the shape can be written on cooling, okay. The shape can be written on this cooling. So in this lecture we discussing the classification of this composite material based on the matrices, okay. The first matrices is polymer. So polymer, we are very much familiar with these polymers, then their classification according to the behaviors after heating and cooling. They are classified into thermosetting and thermoplastic polymers. And another important parameter regarding to this polymer matrix composites, or regarding to this polymer, is the glass transition temperature, okay. The glass transition temperature. So what is this glass transition temperature? What is this glass transition temperature? Glass transition temperature is the temperature at which it is the temperature at which becomes glass becomes brittle, means hard. Okay, it is the temperature, not term, it is the temperature at which glass becomes brittle. Glass becomes brittle on cooling or soft on heating. So it is the temperature at which the glass becomes brittle, that is hard on cooling or soft on heating, is considered as the glass transition temperature. So okay, so these are the some important points. Okay, regarding to this polymer matrix composites. So you should know the polymer, the different classification of the polymer based on the heating and cooling. Okay, another important point regarding to this polymer matrix composite is that in this case, so we already discussed that whatever the polymeric material is your matrix. Okay, so in this polymer matrix composite, the polymer is your matrix. Polymer is your matrix material, and it is combined with combined with a fibrous reinforcing material. Fibrous reinforcing disperse phase. Okay, so reinforcing material, it is also called as the disperse phase. So polymer, it is your matrix, it is combined with fibrous reinforcing disperse phase. Okay, and the second point is also important, that is the polymer matrix composite. Polymer matrix composite Polymer matrix composites are very popular are very popular are very popular due to their cost and simple fabrication method simple fabrication methods. Okay, so these are the two important points. So polymer, it is your matrix, and it will combine with fibrous reinforcing disperse phase, fibrous reinforcing material. So they are very popular due to their lower cost and simple fabrication methods. If you consider the examples, that is natural polymer composite. If you consider the example of natural polymer composite, it is your wood. So this is your natural polymer composite, that is your wood. Okay, so composite with long fibers of cellulose. Okay, so in this natural polymer composite, that is your wood. So we know that the wood, it is a composite with long fibers of cellulose, long fibers of cellulose long fiber of cellulose held together by much weaker substance called lignin. Okay, so the wood, it is a best example of natural polymer composite in which it was The cellulose is your continuous phase, that is your matrices, and the lignin is your reinforcing material. And the second example, that is man-made polymer matrix, man-made polymer composite, not matrix, man-made polymer composite, man-made polymer composite. It is your bricks. So okay, and the bricks are used for building of construction. Okay, bricks is there. Okay, second is plywood also there. This is bricks and plywoods. So this is all about the uh, polymer base, or we can consider the polymer matrix composite, polymer matrix composite. So let us discuss about second, that is uh, metal matrix composites. Metal metal matrix composite. So if you consider this metal matrix composite, it is nothing but the alloy. Okay, so whatever the matrix material, it is nothing but your alloy. Okay, so this is nothing but your alloy. Okay, alloy of alloy. Okay, for example, steel alloy is there, or metal atom. Okay, steel alloy is there, or metal atom is also there. Metal atoms such as aluminum, titanium, then copper, magnesium. Okay, so whatever the matrix material in this composite, it is your metal. Okay, or alloy. So if you consider the properties of this metal matrix composites, they are having high strength, they are having high strength, then they are having fracture toughness, fracture toughness, they are having fracture toughness. They can withstand at elevated temperature in corrosive environment. So they can stand at high temperature in corrosive environment, corrosive environment, and they are widely used in engineering application, widely used in application engineering application. They are widely used in engineering application. Okay, so let's discuss the next one, that is ceramic matrix composite. This ceramic matrix composite, they're having strong ionic bonding, they're having strong ionic bonding. Second, high melting point, strong ionic bonding. Second, high melting point. Third, good corrosion resistant properties, corrosion resistance property, uh, having good stability at high temperature, stability at high temperature, and widely used in engineering application, in which the temperature is lie between 800 degree to 1650 degree. So temperature range, that is 800 degrees Celsius to 1650 degrees Celsius. So these are the important characteristics of ceramic matrix composites, ceramic as a matrix material. Okay, and the last one, that is your carbon and graphite. The last one is your carbon and graphite is there. Carbon and graphite matrix composites. Okay, so they will stand at extremely high temperature. These carbon and graphites, they are used in extremely high temperature, that is from 1930 degrees Celsius to 760 degrees Celsius. So they having high temperature range as compared to other matrix composite. The strength increases at high temperature. Its strength is increases at high temperature. Its strength is increases at high temperature. It having good resistance to thermal shock and high strength and stiffness. So they're having high strength and stiffness. High strength and stiffness. And the fourth one, a good resistance to thermal shock. Good resistance to thermal shocks. So this is all about the classification of this composite material based on the matrices. So based on the matrices, they are classified into four types, that is polymer matrix composite, then metal matrix composite, then ceramic matrix composite, and the last one, that is carbon and graphite. So this is all about the classification based on the matrix material. Okay, in the next lecture we will discuss the classification. It is based on the reinforcement material. Okay, the classification based on reinforcement. Thank you.